Hey everybody, today we're going to talk about sinusoidal functions. So we've been talking about sine and cosine, and today we're going to talk about the fact that any function that is either additive or multiplicative transformation of sine theta is called a sinusoidal function. So what does that mean? So just like when we were talking about transformations of functions back in chapter or unit 1, we're going to talk about sine and cosine. So remember that with sine and cosine, they all come from our best friend, the unit circle. And remember, around the unit circle, we have these points. We call these points at 0 degrees, it's 1, 0. At 90 degrees or pi over 2, it's 0, 1. At 180 degrees or pi, it's negative 1, 0. At 270 degrees or 3 pi over 2, it's 0, negative 1, and then it repeats as we go around the circle. Remember that just like when we have x, y, we have cosine, sine. So if that's true, when I look around the circle, if I want to look at just the sine value, I'm looking at the y value around the circle. So at 0 degrees, we see that sine is 0. At 90, it's 1. At 180, it's 0. At 270, it's negative 1, and then back to 0. So that's how we're going to graph sine. So when theta is 0, sine is 0. When theta is pi over 2, sine is 1. So we know that this is 1. When theta is pi, sine is 0. When theta is 3 pi over 2, sine is negative 1. We'll put that negative 1 here on the graph. And then finally at 2 pi, it's back to 0. So our sine function looks something like this. I'm hoping that you're feeling very familiar with this. Go ahead and continue it all the way. And then we also see that cosine is those x values around the circle. So at 0, it's 1. At pi over 2, it's 0. At pi, it's negative 1. At 3 pi over 2, it's 0. And then back to 1 at 2 pi. So let's go ahead and graph this. This is at 1. It starts at 1. Pi over 2 is 0. At pi, it's negative 1. At 3 pi over 2, it's 0. And at 2 pi, it's back to positive 1. And we're going to connect our curve like this. All right, so once we have our two graphs, you can see that if we look at that cosine function, we know that this is an even function because it has reflexive symmetry over the y-axis, where if I flipped all these points about the y-axis here, it would flip around completely exactly the opposite way. So this one, if I flip it over the y-axis, it flips over this way. This would flip over here and so on. And then for our sine theta, we call this an odd function because it has rotational symmetry about the origin. And what that means is that every point on the sine function, it's going to be 180 degrees flipped across the origin. So from here, it's going to translate over to this point here. So this is 180 degrees away, so that would be over here on our function. So if we look at these two functions now, I'm going to go ahead and highlight that sine is this function here. Go ahead and take a highlighter and highlight your functions. And let's highlight our sine function. We'll do this one in purple, or cosine function, I should say. Here's our cosine wave. Okay, so if I look and I'm really analyzing what's going on with these two functions here, I really know that cosine is really just a transformation of sine. We can see that they're the same shape. We can see that their curvature is very similar. So for example, if I analyze this, I can see this point here is a maximum for sine. And if I just shift it to the left by pi over 2, so this distance here is pi over 2 to the left, we can see that there's the maximum for cosine. We can also see this here at every 0 point on sine. If I shift it to the left, pi over 2, we can see that it also lands on the cosine 0. So we can say that, hey, cosine is just the value of the sine function shifted to the left by pi over 2, or otherwise known as a phase shift, okay? Remember that our two standard equations are y equals a cosine theta, where a is the amplitude, and y equals a sine theta, again, where a is the amplitude. So remember, the value of a is the amplitude, which is half the difference between the maximum and minimum values. The midline is a horizontal halfway between the maximum and minimum values, okay? So it's determined by finding the average of the maximum and minimum values, or the sum of the max and min divided by 2. And the concavity will change as it crosses the midline. This is a big deal. So we know that the midline for specific a cosine theta and a sine theta is normally y equals 0. Of course, if that gets shifted up or down, that might change, okay? Let's talk about what the period is. The period, as we go around this, how many times or how long theta has to be to get a full cycle. So we say that's 2 pi divided by the value of b, where b is the number of cycles that happen within 2 pi, and the frequency is the reciprocal of the period. So if 2 pi over b is the period, then b over 2 pi is the reciprocal. This tells me how much of the frequency is within 1 radian, or how many patterns are within 1 radian. So let's talk about that. Let's do some examples together. So it says graph the following sinusoid functions. So here I know my amplitude is 3, which, because there's no shift up or down, I know my maximum value will be 3 and my minimum value will be -3. If I graph just regular sine, I'm going to graph regular sine in gray. So I know sine starts at 0, at pi over 2 it's 1, back down to 0, at 3 pi over 2 it's -1, and so on. So this is normal sine, okay? That's our y equals sine theta. If I'm going to graph 3 sine theta, I know I'm going to multiply everything by 3, meaning our vertical stretch, that amplitude is 3. So everything on 0 will still the same. 3 times 0 is still 0. But this maximum 1 is now going to be multiplied by a vertical stretch of 3. It's going to come back to 0 at pi. Our minimum is going to be now at -3, and our 0 will still be there. So our graph kind of looks like this. Whoops. Okay, so then let's look at our x-intercepts. We see x-intercepts here, here, and here. We know what happens at 0, pi, and 2 pi every pi. So the way we're going to say that is we say that that's pi times n, where n is the integers. All right, let's talk about f is 2 cosine theta. So we know our amplitude is 2. Because there's no vertical shift, we know the maximum will be 2, the minimum will be -2. Let's go ahead and graph 1 cycle of cosine as it normally would be. So we know our maximum and minimums happen at -1 and 1. So cosine starts at -1, at pi over 2 it's 0, at pi it's -1, 3 pi over 2 is 0, and 2 pi is back at 1. So we've seen this before. We should be super familiar with it and able to recreate that. Remember that this is y equals cosine theta. If I'm going to graph 2 cosine theta, I'm going to multiply that, stretch it vertically by 2. So instead of our maximum being at 1, we're going to multiply it by 2. Here's our maximum at 2. 0 times 2 is still 0. Our minimum at -1 is multiplied by 2. That becomes a -2. Back to 0. And then again, our maximum's up at 2. So this is our graph of 2 cosine theta. And then we have our x-intercepts at pi over 2, 3 pi over 2. It's going to happen every pi over 2, and these are a whole pi apart. So we're going to say that's every pi over 2 plus a pi distance between each other. And so that means it's at every pi over 2, and they're all 1 pi apart. Let's look at this one. So we've got -2 sine theta. Remember, the amplitude is going to be the absolute value of that a. So the amplitude is still 2. Our maximum value will still be above the line at 2. Our minimum value will be at -2. So let's sketch again one cycle of sine. So here's sine. We know how to graph that pretty quickly. Notice that they've given us extra room to the left of this graph, so we can do 2 full periods of sine. Okay, so here's sine x if it's a regular, no transformations. Let's go ahead and graph what -2 sine x. Remember that -2 is also going to be a reflection or a vertical reflection over the x-axis. So that means on the x-axis, everything is going to stay the same. But as everything else moves, it's going to be reflected around that x-axis, as we see here. And then we also see that everything gets multiplied by that 2. So by that -2. So our maximum is going to be at 2, our minimum is going to be at -2. And instead of increasing up to a maximum, because we're multiplying and flipping that negative, we're going to decrease down to a minimum first. So we're going to go a minimum instead of a maximum at pi over 2 back to 0. Now we're going to be at a maximum instead of a minimum at 3 pi over 2. So our right side of our function is going to look like this. And we're going to continue that pattern as we go to the left of our graph. And this is our y equals -2 sine x graph. All right, last one. Let's look at our -4 cosine. So again, this is a vertical reflection over the x-axis. And that means we're going to take and flip everything over the x-axis. Let's sketch one cosine graph the way it normally would be. Notice that we've got enough on the right and the left to do 2 full periods, okay? So again, this is y equals regular cosine x. So let's go ahead and sketch -4. So I know amplitude is the absolute value of -4, so our max value is 4, minimum value is -4. And here, I'm going to remember that if it's reflecting over the x-axis, everything on the x-axis is still the same. So all these x-intercepts are the same. But instead of starting at a maximum of 1, we know everything's going to be going up to 4 and down to -4. But instead of going up to a maximum, we're going to start at a minimum, 0. This will now be a maximum. And then here's our minimum. So we see this as we go to the positive values of pi. And then we're going to do the same thing, but instead of a minimum at -pi, we're going to be at a maximum. And instead of a maximum at -2 pi, we're going to be at a minimum. And these are my graphs to the right and left. So remember, our x-intercepts, which we'll have to go back to number 3, is always at pi over 2 and 3 pi over 2 and every pi. So we say that's pi over 2 plus pi n. And then we forgot to do, or I forgot to do the x-intercepts here. We see them every 0, pi, and 2 pi, and so on. So that's going to be every pi n. Okay, let's do a couple more, and then we'll be done. It says for each problem, the sinusoid has been vertically shifted, and the maximum and minimum values are given. Write the equation of the midline and find the amplitude. So remember, if we've got a maximum and a minimum, we know that the amplitude is the average of the maximum minus the minimum value. So let's find it. So 100 minus 20 divided by 2. Well, I know 100 minus 20 is 80 over 2 is 40. So there's my amplitude. I know in order to find my midline, I'm going to take that minimum value and add the amplitude. And that's going to give me my y-axis or my midline. So my minimum value was 20, the amplitude was 40, therefore it's 60, so I know my midline is y equals 60. Okay, let's look at this next one. It says the maximum is 135, the minimum is 90, so my amplitude is going to be the maximum minus the minimum, all divided by 2. That's 45 over 2, which is 22.5 as the amplitude. And then to get the midline, we know that it's y equals the minimum value, which was 90, add the amplitude, and we get 112.5. And there's my midline. Thanks, guys. We'll see you next time.